think. Are we ready to start? Yeah, there we go. It seems there's a lot of people here, so maybe like slightly squeeze inside if you have a couple of empty seats beside you, because I can still see a couple of people trickling in. Thank you so much for showing up in such a wonderfully huge crowd. All right, great, cool. Well, I was instructed that we're going to get thrown off after exactly 45 minutes, so we're going to start. Hi, everyone, and welcome to our session on Compose Multiplatform on iOS. My name is Sebastian. I'm one of the Kotlin and Compose Multiplatform developer advocates at JetBrains. You may have seen me before, maybe on our YouTube channel, maybe on Twitter, I don't know, somewhere like that. And I'm joined today by my wonderful co-speaker, Nikita.
Hello, everyone. My name is Nikita Lipsky. I joined Compose Multiplatform last summer because I liked so much the whole concept of composable functions. I believe it's something new, not only in UI programming, but in programming in general. Before that, I used to be a JVM developer, so I'm quite fresh in Compose, so please don't ask me how to do in Compose this or how to do in Compose that.
All right, with that out of the way, we can get started, and we can just get right into the thick of it after our formalities. Compose Multiplatform is coming to iOS. That enables one of the very cool synergies, which is being able to write a user phase once and then share it between different platforms. So we're going to take you on a little bit of a journey today. That's going to, of course, include Compose Multiplatform on iOS. We're going to see a bunch of live demos, a look at the architecture and how that whole implementation actually works, and how you can get started writing your own shared user interfaces today. First, let's do a super brief recap on the classic Kotlin multi-platform case. We're just looking at the mobile case here because that one's probably the most popular, but this, of course, easily generalizes. The idea was always to share the code that's supposed to behave the same on multiple platforms, but not give up access to platform-specific APIs and capabilities. But there's kind of one part missing here, and that's a solution for when you don't want to build and maintain native user interfaces for your target platform separately. Because maybe you don't have enough people, maybe you don't have the time, or maybe because you just really, really want to get your app out there, out of the door, and in the hands of as many people as soon as possible. That's exactly the thing that Compose Multiplatform enables. It allows you to implement your user interface once and then use it for all the platforms that you target. In this scenario that you're seeing here, that's iOS and Android, but you can absolutely throw desktop and web in the mix as well. Because it is worth pointing out once again that Compose Multiplatform is actually the JetBrains initiative to enable cross-platform UI across various parts of the ecosystem. So in late 2021, we already stabilized the desktop target for Compose Multiplatform, which provides you a really delightful way to build user interfaces for Windows, Mac, and Linux. That would be a wonderful talk in and of itself, but it's not going to be us who's going to give it. Instead, we're going to leave that to Victor Kropp, who's going to have his talk, You Can Desktop Too, tomorrow at 1 p.m. And if you want to kind of get hands-on, there's also a lab tomorrow at 2 p.m. where you can write some Compose for Desktop code yourself. Within the context of Victor's talk, you're also going to hear a little bit about the story of one of the Compose Multiplatform apps you may have used yourself, which is, of course, JetBrains Toolbox. Another big target that we saw today is Compose Multiplatform on the web. Once again, that could fill easily its own talk, but it's not this one. So if you want to learn more about that, and you're physically here in the room, like a lot of you are, then I would suggest stopping by the booth after this talk. I hear there's a couple of very enthusiastic people with very cool demos. I am one of those people. So you can also come up to me. I also have that demo on my laptop. Anyway, today we are going to spend our time talking about this new and shiny iOS target. Now, all of Compose Multiplatform that we build at JetBrains builds on top of Jetpack Compose from Google. As we've seen in the keynote today, that's already a very well-established UI framework that's built on 100% Kotlin. And when Nikita is going to talk about the architecture of Compose Multiplatform, we'll see how closely we actually are related. But for you as developers, the gist is that whether you're an experienced Compose developer or you are one of those hundreds of thousands of developers that are learning Jetpack Compose, you are in luck. Because except for a few minor differences, the APIs in Compose Multiplatform and Jetpack Compose, they are the same. That means any knowledge that you already have on how to build user interfaces, that translates very directly, as we'll see in just a bit. In other words, if you've built a modern Android user interface, that means that you can use those exact same skills to write interfaces for iOS and beyond as well. It's a real multiplier to leverage your skills on a whole new level. The best part about all this hyping up that I've been doing is that you don't actually have to wait to get your hands on this kind of technology. We are releasing Compose for iOS as alpha today within the context of Compose Multiplatform 1.4. I cannot tell you how excited I am about this. I saw someone trying to clap, so let's do that. So a little behind the scenes look, I had the pleasure of working with a couple of the pre-release artifacts for the last few months, and it has been absolute agony not being able to tell other people about this. It's really, really exciting, and I think you are going to get just as much excitement out of it as I did. So we have a lot to talk about. We need to figure out where Compose for iOS currently is, what it means that it is alpha, and where we're going with it. We'll do that in just a second, but first I think it's time we remember this moment and make a memory. And I mean that quite literally. I have a little app here called My Memories, which I'm just going to pull up here on the screen, which is running on my iPhone. And this is, of course, built in Compose Multiplatform. That's a great picture up there already. So just like a regular demo app, we have everything you need, right? You have stock photos, we have cute cats, and we have, high-resolution images of architecture. But this actually also contains a couple of real memories that I made, like that one time when I was in a software engineering class, and I solved an exercise really, really quickly, so the professor handed out this little donut to me, and I'll treasure that forever. You can actually see that if we look into this. There's a little description attached to this as well. But of course, the picture that I want to take a look at a little bit closer is the cat. So this is actually the cat of a good friend of mine. If you do read this description, you'll figure out that she's very, very fond of soups, which is why if we actually look at the map of where we've located her, she's at one of the very nice soup restaurants in the middle of Munich. And you can see that it's very central because it's right next to the main church that we have in Munich. So you can kind of see that one right here. Sweet. But of course, those were all memories in the past. They were all good memories, and I feel like being here today is just as good. So I would love to make a little bit of a memory with all of you. We're going to take a bit of a picture. I know there's a couple of people here with the orange lanyard, so please provide the sponsored censorship. And just do that maybe, because otherwise you might be in the background of this. And of course, I'm not alone here, so I actually want to have Nikita make the same kind of memory for us using his Android phone.
Yes, it's the same application, but on Android.
So let's, I think we'll start with my selfie and then we'll do yours. Let's see here. You can wave or something else like that. Look at that, wonderful. And we'll do that one more time. Excellent, look at that, wonderful. Now those are some great images. All right, we can take a closer look, if we're just...
Let's share it.
Yeah, I think maybe we do some censorship, I don't know. Yeah, let's share that one, and maybe we can collect a couple of retweets by the end of the session. Not that we encourage you to pull out your phones right now or anything. Let's just tweet this one.
Just tweet.
Wonderful, and it's out. Great. Thank you so much for being part of that. Okay. Now, I'm not sure if you could tell, but this was actually just a kind of a mock scenario. I wasn't actually just trying to take a picture of all of you. I was trying to show you all the things that Compose Multiplatform could already do. So let's actually kind of dissect all of this a little bit. Because I was very much involved in the implementation of this app together with folks from the Compose Multiplatform team. And just to share my own experience, it was almost frightening how quick I was able to be productive with this. Because I said this before, that kind of the APIs are the same, but that was a very abstract statement. So let's actually look at this app and see what we have here on the screen. This image right there, that's an image component, like that's an image composable from Compose, the same one that you know from Android. I don't mean it's a re-implementation or it's kind of the same. It's literally the Android X Compose Foundation image. It's the same one. This grid down here, that's just a lazy vertical grid. So it uses the exact same kind of APIs. You use the same kind of item syntax, all of that. It's just the same. We went a little bit fancy with the button. We could have, of course, just used a regular button, but you know how it is. You just use a box with a modifier of size 50, a circle-shaped clip, and you add a little bit of clickability, and then it works just as well. We could have used the built-in one, but we wanted to be a bit fancy, and we also wanted to show you that all the modifiers that you're used to from Android, potentially, those are all in there as well, and they behave just the same. Now, this topic actually stretches to most of the UI topics that you've seen. The animations and fading that all uses the same DSLs as on Android, the little parallax effect that we had when you scrolled up and the cat would scroll a little bit slower, that's also just built on top of the regular APIs, as are the transitions and so on. So the main takeaway from this is just you're building on the same building blocks as all the established Jetpack Compose apps. So it's really, really quick to get started. But of course, we also saw a bunch of stuff that wasn't just Compose. Right? Because just like any other fully featured app, we want to make use of what the platform has to offer. We showed you two of these examples. We had the MapKit map, which also had this nice little 3D animation in there. And of course, we fed that using the core location, like sensor data, so that it's actually the real GPS. And you saw the camera view, which actually uses AV Foundation, which is another Apple-specific API. And still, we managed to put things like compose buttons on top of that. Nikita's going to tell a little bit more about how that actually works from an architecture perspective. But for these kind of platform-specific widgets that are kind of complex, it is one of our goals to provide smooth interoperability. Yeah, so that's the composable button. Very good. Talking about this being one of our goals, it's probably a good segue to manage some expectations and let you know that not everything is finished yet. Remember, this was all very flashy, but we have only just reached alpha. It starts from very, very simple things, right? There's stuff like scroll physics that might feel not exactly as they are on the underlying system, or the way that gestures behave. It extends further to stuff like navigation principles and transitions, and other complex interactions like text selection or input management, dialogues, and pop-ups. But you already saw that we can do things like pop up the share sheet and just kind of integrate with other apps quite easily. So that's kind of cool. And of course, we also want to provide solid accessibility integrations. We want to respect user choices. We want to make sure that text-to-voice works properly with your apps, that zoom and contrast settings, that those all work as you would expect them to. Granted, this is a lot of points, but we really do want to put in proper thought so that your shared user interfaces feel great regardless of the platform that you use them on. One more topic that is, of course, also currently still work in progress, and that's really important, is providing absolutely smooth performance even on high refresh rate displays, so 60 or 120 frames per second on the higher end devices. Nikita's going to tell a little bit about what's going on in that regard in just a little bit. Okay, expectations managed, wonderful. We can kind of conclude our thread on what we saw in the demo. Under the hood here, we of course had a bunch of things that were just built on top of regular Kotlin multiplatform. This isn't actually Compose multiplatform specific. Stuff like concurrency, networking, persistence, and business logic. But it's worth pointing out once more that this is indeed a Kotlin multi-platform project. This is really good on the one hand because it means that you get native binaries on iOS through Kotlin native. But it also means that you can't just flip a magic switch and expect your Android app that you already have to just magically work on iOS. You still have to turn it into a multi-platform app. Luckily, for that use case, the same kind of approaches apply that have always applied in in Kotlin multi-platform apps, so things like expect and actual. And of course, as we already saw in the keynote for a little bit, a lot of libraries that might be Android-specific already have multi-platform counterparts that you can use that help you in your migration towards providing an implementation for multiple platforms. We already saw a huge part of this catalog already during the keynote. Svetlana showed that one. And yeah, there's really a lot of multi-platform libraries that cover most common use cases in your app. We want to take this opportunity to once again shout out Google for pushing their Jetpack libraries to multi-platform as well, so beyond Compose. That will make it even easier to bring Android applications to other platforms. What's especially cool is that there's also a bunch of libraries out there that are actually already working on Compose multi-platform specifically, like specific composables or navigation libraries. And now that Compose for iOS is available in alpha, I'm sure that those trailblazers won't take very long to support that target as well. Okay, but how did we actually make Compose multi-platform? How does all of this work under the hood? Those are questions that I cannot answer, but thankfully I have someone who can, a real professional. So you take it away, Nikita.
So first, please explain what is Compose multiplatform. So we have Kotlin multiplatform, and we have Compose that is written in Kotlin. Oops, Compose multiplatform. By the way, Sebastian, do you see an apple in this sculpture?
I very much do.
Yes, but it's not the right apple. This apple is much better. Let me choose the apple and swallow it. So let's now talk. Oh, swallow it. So now let's now talk how we've made Compose multiplatform. Compose multiplatform project started just between Jetpack Compose official announcement and its first public release. So we started early. Jetpack Compose is a part of Android Jetpack suite of libraries that lives on GitHub repository called Android X. Jetpack Compose is fully written in Kotlin. And to make a Kotlin library as Kotlin multi-platform library, you have to define Kotlin multi-platform source sets for the targets you're going to support. So we just followed this way. And to make the story short, if we go now to Android X GitHub repository and navigate to Compose UI sources, the most low-level part of Compose, we may find that it defines Kotlin multi-platform source sets. So official Jetpack Compose is Kotlin multi-platform right now. And yes, Google mostly writes their code as common Kotlin. It's not that amazing. It allows us to reuse Google Works for other targets that we are working on. Thank you, Google. You know that writing a code in a common source set imposes certain restrictions on what you can use and what you can't. So our regards to Google that they do it. Actually, we collaborate with Google in Compose multi-platform development, and we regularly port, and we do our development in a repository called Compose Multiplatform Core, and where we maintain additional targets supported by Compose Multiplatform. And we regularly port our changes in common code back to Android X repository. Talking about additional targets, if we navigate to Compose UI sources of Compose Multiplatform Core, we may note not only Android and desktop targets, but we can also note source sets for web and iOS targets that are called JS main and UI kit main respectively. By the way, among the source sets, you may also note Skiko main source set. It is actually a common source set for all our targets except Android, containing most of the code of our port. But what is Skiko? So let's now talk about Compose multi-platform architecture. And to understand how Compose multi-platform and Jetpack Compose relate, we first need to understand the architecture of Jetpack Compose itself. So the most low-level part of Compose that deals with layout, drawing, input is Compose UI that defines basic blocks for UI construction. Compose Foundation is based on Compose UI and provides basic layouts like column, box, lazy column, gestures, text, etc. Compose Animation is on top of Compose UI and Foundation. And on top of it, design systems with common widgets are provided like Material or Material 3. To write Compose applications, you need Compose compiler because the whole concept of composable functions is actually an extension to Kotlin language that needs compiler support. And the whole Compose system is managed by Compose runtime. So it was about Jetpack Compose itself, about the architecture, about the different parts. And on Android, Compose is managed by Android, of course. And probably you know that Android uses Skia graphics engine for all rendering stuff. By the way, Chrome also uses Skia. And we decided to use Skia as well for other targets for Compose Multiplatform. Skia is written in C++, so we wrapped it with Kotlin bindings and named it Skiko. So now you know what is Skiko main. This is where Compose Multiplatform comes into play. Most of the code of our port is in Skiko main source set, but of course there is some code for individual targets as well. But most of the code of Compose Multiplatform is just shared with Jetpack Compose, except some parts that are too Android specific, like resource management, that we will talk later. And if we talk about iOS port, the whole system is managed by Kotlin native, compiler, and runtime. Compose is exported to an iOS application in the form of UI view controller instance, so it can be consumed by UI kit or Swift UI in any place. Let me show how to do that. So first, you define your UI stuff in common main source set. Then you export your UI in iOS main source set in the form of UI view controller using Compose UI view controller wrapping function. The function just gives Compose a canvas, and Compose draws all your UI on that canvas using Skia. Easy. And returns UI view controller back to the iOS world. Finally, you just use exported function in your Swift sources. You may use Compose as individual screens or as a whole applications, like in my memories that we've shown. But you can also embed Compose into your UI, your Swift UI screens, like in the chat app on the right, where top and bottom bars and text input are Swift UI elements, while chat view itself is written in Compose. That allows you to gradually adopt Compose Multiplatform in your existing projects. Kotlin interop works great here. However, it can work opposite way as well. You can wrap UIKit widgets as composable function using UIKit view composable function and use it within Compose use. Here we will wrap mkMapView iOS map, native map view widget, and note that it's just pure Kotlin code that references mkMapView directly, so you don't need to write any Swift or Objective-C code for this. Then you may use wrap native map in memories view, and you can also wrap other complex widgets like camera or web view. But please don't overuse this approach. You know that mixing different UI frameworks on the same screen always has issues. So please don't embed Swift UI into Compose, Compose into Swift UI recursively on the same screen. But we believe that this approach should work for complex widgets like camera or web view that we aren't going to re-implement. But you may ask, OK, it's clear. But what about performance? Does the scheme perform well? So if we talk about the performance of UI applications, we actually talk if we can fit into 60 frames per second or even 120 FPS for modern devices. And it means that we have only 16 milliseconds or even 8 milliseconds to do all rendering stuff within a frame. And if something heavy appears in the middle of our rendering process, if we do something heavy in the main UI thread just for 16 milliseconds, we immediately lose a frame, and users will notice it and will perceive it as a lag. Now recall that Compose for iOS is managed by Kotlin native. Please note that Kotlin native is not just compiler. It not only compiles your sources into native code, but it also provides a managed runtime. And that runtime has garbage collector. By the way, if you appear to try Kotlin native 2 years ago and faced with the problem that it's hard to write multi-threaded code with it, it's not the case anymore. Now multi-threading semantic is the same for all Kotlin targets, so you don't need to use freeze method for shared mutable state anymore. But it resulted that garbage collector had to be re-implemented, and it is not reference counting anymore. But classical mark and sweep, where sweep phase is concurrent, but mark phase is not unperformed in GC pose. So GC pose linearly depends on a number of live objects. So for now, GC pose is exactly that heavy thing that can appear in the middle of your rendering process, causing your app losing frames. And unfortunately, yes, we observe 16 milliseconds GC poses on users' applications now. But good news that Kotlin native team is working on fully concurrent GC, and we believe that we can achieve 2 milliseconds GC poses that should be enough for your applications to not lose frames. So if you try Compose Multiplatform for iOS and see that the performance is not good enough, please don't throw it away immediately, but first, make sure that you compiled your application in a release mode. It is very important. And then you may try to disable garbage collector to estimate the future performance. If you disable it, your application won't crash immediately with out of memory, but you can compare if the performance is smoother or not. If it is not performant enough, anyway, please share us your use cases because we are evaluating the performance right now. We believe that it's very important for the project to be successful. We work closely with Kotlin native team to improve performance, so please provide us your feedback. And here's my the hood part comes to end, and I give the floor to Sebastian.
All right, wonderful. So now that we even understand how things are working internally, I think it's time for us to get into Compose for iOS and do a little bit of a live coding demo. Those are always fun, you know, keeps the heart healthy, keeps the heart rate up. So I love doing those. Little side note here, of course, if you are working on an iOS app and you want to build and run that on a simulator or on a physical device, you need to have a Mac or you need to run on macOS. That's not a limitation from us, that's a limitation from Apple, very unfortunately. But how do we kind of get started with all of this? Well, the answer is, of course, found on the homepage of Compose Multiplatform. We'll put a very big short link on this and on the slides in just a little bit. Now here you can explore a bunch of wonderful text that we've worked a long time that tries to define what exactly Compose Multiplatform is, but most importantly, it also provides you a direct entry point to our templates. So in this case, what I clicked on was the iOS target, which sends us to our multi-platform iOS and Android template, which allows you to build applications for exactly those two mobile targets. I do not trust the Wi-Fi that we have here in the venue, so I have taken the liberty of already importing and starting up this project, and we can just do a little bit of exploration. Of course, first we need to make sure that our setup is properly done though. So the correct way to do that is to run KDoctor, which is our tool for diagnosing your development environment. It checks things like your operating system, that you have the correct versions of Java, Android Studio, Xcode, and CocoaPods set up. And it also provides a bunch of other convenience functions in regards to signing and so on that might be useful if you're running on physical devices. I also made sure that in my Android Studio, I have actually installed the latest version of the Kotlin Multiplatform Mobile plugin, because that is the part that enables us to run our application on emulators or physical devices using the run configurations. So before I do anything else, let me just start these compilations so that they can kind of just run in the background while we go and explore for a little bit. If you first open the project, you're going to see something quite similar to this. Because Android Studio has Android in the name, you're going to see the Android view first. And we're just going to switch that one to project because, well, we're doing multi-platform development here. And if you've ever done multi-platform development before, this is a structure that might already be quite familiar to you. Spoilers. So you have your Android app here, you have your iOS app here, and you have a shared module. And then inside the shared module, you once again have 3 parts. You have your actual common code that's shared between all platforms, and then you also have your Android main and iOS main parts, where you can, if you're using the expect actual mechanism, you can write some Kotlin definitions in there that are specific to a target. Before we actually dive into the code, we can also take a brief detour into the build file, where we can see that a couple of the claims that I made before are in fact true. This is a Kotlin multi-platform project. It also builds on top of the Compose Multiplatform Gradle plugin, which provides a bunch of convenience things, like, for example, defining the common dependencies on runtime, foundation, and material using this wonderful little syntax that makes sure that the artifacts you pull into your project are always compatible with each other. If I just press Control Space here to invoke the autocomplete, we see that I put my cursor just off by 1 space, and we can see that you can see all the things that are available here for you to import. Right. That is, of course, something that is best explored at your own leisure. So where does the actual application then live? Well, as you can see, that's just in our very, very shared module between all the platforms. And here you can see that this is just classic Compose code. If you've done Jetpack Compose before, this should be mostly self-explanatory. We use remember to manage some state together with the mutable state of. We have a button that defines an on-click handler and a bunch of text. The only thing that might be new to you if you're not a multi-platform developer yet is this getPlatformName function, which is actually defined as an expect actual function. So it has different implementations based on the platform that you target. For example, if I go into the iOS version of this, we'll see that it returns indeed iOS, versus the Android one would probably just return Android. Okay, so we have probably a mental model of what this app looks like now, and we can validate this by indeed running it, and we'll see that on Android, we get Hello World, which changes into Hello Android on a click. And if we go into our iOS simulator, we get Hello World, which changes into Hello iOS. Sweet. Little boring, so I suggest we make it maybe a little bit more interesting, because we saw, right, I made all these claims, well, animation APIs work the same, and you should be able to get started pretty quickly. So if you've done Compose, you can probably follow along with me as I add an image component that is inside an animated visibility component, and then we'll do a bunch of layout around it, and we'll make it so that it animates in and out as I click. Okay. Classic approach. We want to have some kind of state that remembers whether we want to show the image or not. That's just a Boolean variable. We're just going to go into this on-click handler and invert that one every time we click the button. Wonderful. Then we need a little bit of layout primitives, because we don't want everything rendering on top of each other. So let's stuff our button and whatever else we create into a column. And while we are at it, we might actually also want to add a couple of modifiers. So we want to make sure that this one is the maximum size. And I don't know, let's see here. Since these are the same APIs, I can just invoke my my little hints here and see, well, it seems that probably the horizontal alignment would be nice to have something like centering everything horizontally, just to make it a little more aesthetically pleasing. Okay, so we're still currently just rendering a button, so let's make sure we also render an image. And this is one of the parts where what Nikita said is also going to come into play. Because usually if you were just developing on Android, you would use the R class here, right, to access your resources, the images that you have. But we want to make it possible for you to manage resources in your common modules as well. So in this case, I have a vector XML in here that is shared between all the platforms. So what Compose Multiplatform actually does is it provides you with alternatives, with implementations that allow you to do exactly this kind of cross-platform resource management. In this case, that will be a painter resource, and then we'll just type the name of that one in here. And of course, we need to also provide a content description, which we'll keep null for the time being. We can actually navigate into painter resource to see that this is indeed defined as a common function, so that one is just available from Compose Multiplatform specifically. There's not much animation going on here yet, so let's just use one of the very basic animation APIs, animated visibility. We can just give that one a, we'll just give that one a Boolean, and then we'll kick off the running of these two apps again, and we'll see that this indeed hopefully behaves the way that we want to. So we can already see that the Android version has already finished, and indeed, first good sign, everything is centered, so at least the layout seems fine. And then when we click on this, we get the correct resource, and it kind of loads, and it pops in and out. Very, very satisfying. Great. So moving back to the iOS simulator, we can see that we get the exact same user interface, and as I press, this also animates in and out. Wonderful. Okay, so but there's a couple of questions here, right? Which is, okay, so we have all of this, but what does it look like from a tooling perspective? Can we debug? Can we profile? And for all of that, I'm going to hand over to Nikita again, and he's going to demo a little bit about that.
Okay. So please first let me show that debugger just works. So we just set a breakpoint. We are on yes, and start the debugger, and debugger stops at the breakpoint. And we see the stack of current thread. We can also examine other threads. But let us find a hello world string within the debugger. Currently, on top of the stack, we see some compose magic because we are now in the remember function. So let us find an appropriate frame where greeting text is declared. And here it is. Please note that by keyword actually maps a local variable to some field of an object, and debugger shows just that object. And we should find our hello world text in the fields of that object. And here it is. So debugger just works. But we can actually profile our application as well, using just standard profiler that comes with Xcode called instruments. So let us start profile our application. And then nothing happens on the screen, so we don't see any CPU consuming, right? Except some suspicious peaks that should happen. OK, let us check what are they. And we see that it is just GC pose. But let's make something happening on the screen. And we see that CPU starts consuming, and let us check what are inside. Personally, I don't like how instruments shows profiles, but fortunately there is an amazing app called SpeedScope app that can import instruments profiles and show them as a flame graph. And let us check what are inside. And here we see that we do some drawing. Yes, we do some drawing. We do it via compose layer, scale layer, and finally we do compose scene render. And let us check what are hot methods. And we see again here GC, we see some memory allocation, we see GC again, and GC again, and synchronization, memory allocation, coroutines, and we see compose as well here, right? Compose also works. So we can evaluate performance using just standard instruments that comes with Xcode. So thank you for your attention.
Wonderful. So I think there's still one question that might be on everyone's mind, at least a little bit. And that's the question of what does it look like, right? Because so far we've shown you very consistent user interfaces through the power of just drawing on a canvas. But of course, these look very much like Android. The reason for that is because, well, we are building on top of Jetpack Compose, and out of the box, what you're getting there are Material and Material 3 components. The good thing is that these are quite customizable. which is nice. So you can kind of style them, you can imbue them with your own brand, and you can kind of already make them a little bit yours. But I also want to say that we don't really have a conclusive answer just yet about what the future should look like with Compose Multiplatform. It's always one of those key decisions that multi-platform or cross-platform user interface libraries and frameworks have to make. And this is a decision we don't want to make without first having consulted with the community and understanding what it is that you need the most. Personally, I hope for a future where we can all just agree on one delightful looking interface paradigm. I think everyone would be best served with something like this. And I think everyone can actually tell what's a button and what's a text field and all those kind of things. But for real, please do join this conversation with us. It's important for us to really make sure that you get an excellent experience on cross-platform, and we want to work together with all of you and understand what it is that you need to make sure that everything looks and behaves the way that you expect it to. Okay, that was a joke, by the way. Disclaimer. Yeah, okay. From here on out, it's essentially just your turn. If you are an app developer, go and experiment with Compose Multiplatform. See how it can benefit you when you're sharing user interfaces in your apps. I do want to remind you once more that this is an alpha release. So there are things in here that aren't going to work. But you also saw that there's a lot of things that are working just fine. And we'd really love for you to play with it and help us evolve it into something that's a joy for everyone to use and develop with. Yeah, but since it is an alpha, maybe don't use it in your production apps yet. Unless you're one of those daredevils like TouchLab when they built the conference app for DroidCon New York City while Compose for iOS wasn't even released, but they still built it on top of it. I mean, do what you want. I'm not your dad. I also was approached about 5 minutes before we started our talk from one of our folks at the Kotlin team that apparently here at this conference, there's a couple of folks from a logistics app that already use Compose for iOS to support their share of drivers that are using iOS, which, again, impressive speed. I don't know if they implemented that since the keynote or since when, but apparently they did that. So that's quite exciting. All right. Yeah, you can get started by going to jb.gg/compose, where you can find everything. It's just a couple of clicks to also get to the issue tracker to get an idea of where we currently are, what's not working. And of course, that is one of the places where you can leave feedback for how you envision the future of Compose Multiplatform to be. We also want to be in a clear dialogue with all of you. That you can be in using the Compose iOS channel on our Kotlin Lang Slack, where a lot of the developers from the team are hanging out directly, answering questions, and so on. For your own exploration, we've prepared a number of examples that you can explore in the examples subdirectory on the Compose Multiplatform GitHub project. This includes the demo that you've seen today. It includes what Nikita has shown for SwiftUI Interop, but it also shows just a couple of more basic apps like a to-do list application or something like a code viewer, for example. If you've been following the whole Kotlin multi-platform story for longer, you might be familiar with the production samples that we've built. These now also have branches for Compose implementations for the user interface, so you can see kind of what the differences are and you can compare. And if you want to stop by the talk of two of my colleagues on Kotlin X libraries, where you can learn about a lot of cool things, you'll also see a Compose multi-platform application there as one of their big demo projects. So isn't this exciting? Compose Multiplatform on iOS is now in alpha, and it allows you to write UIs using the APIs that you've already seen in Jetpack Compose. You can still interoperate with the underlying platform, and you still get the same kind of powerful abstractions. Don't expect everything to work perfectly just yet, but do explore it, and please give it a try. We want you to get involved, and we want you to go and build awesome things. So please give Compose for iOS a shot, and let's stay in touch. Thank you so much.
Thank you.
Thank you.